Welcome to the first video of Remote Teaching Term 3 for Year 11 Journal Maths. This is Lesson 2, Recurrence, Relations and Sequences. The learning goal for this lesson is to look at the terminology for number sequences and also see number sequences in the ClassPad calculator. The success criteria for this one is to establish a recurrence relation for a sequence and vice versa, and to also construct a recurrence relation in your ClassPad calculator to obtain a table of numbers and also a graph. The class notes for this can be found on Microsoft Teams and also in Compass. So recurrence relation and sequences is a mathematical rule that generates a sequence, like for examples in the previous exercise in AA. The difference, however, is the notation that we use, and the following definitions explain the notation here. So an iteration is one repetition of the process, and the repetition of the process just means if we start off with a certain number, let's say for instance 8, and our rule is to say plus 2, then one iteration means that we go to the next value 10. So right here I've just conducted one iteration. If I were to conduct 2 iterations, I would add 2 twice to get to 12. So that's just what iteration means. It's just a one repetition of the process. This is V subscript 0. So see how there's a little 0 here next to the V? This is just pushed down and to the right of the letter V, which is the opposite of a power. Usually a power goes on the top right, this is on the bottom right. And this just is the starting term of a sequence. And this can also be referred to as A, because A is just the first letter of the alphabet. Very inventive. So V of 0 is just a starting term of a sequence. V of n is the term of the sequence after however many iterations that we want. So if we're talking about a specific term, maybe we want to talk about V of 3, that just means after 3 iterations, what is our value going to be within that sequence? So we'll take this example here. The next example, or the next term rather, is 14, because we're just going to add another 2. So this is our initial, which is not V1, which is V0. After 1 iteration, this is going to be V1. After 2 iterations, this is going to be V2. So 3 iterations, or 3 lots of adding 2 together, will take us to 14 for this arbitrary example anyways. So V of 7 is a term after 7 iterations, and this is deemed as the 8th term within the sequence, and it's not the 7th term. And the main reason why this is the case is based on the fact that the initial of any sequence has been dictated by V of 0. So if we were to look at V of 3, this 14 isn't the 3rd number within the sequence, it's actually the 4th one. 1st, 2nd, 3rd, 4th. But people get confused. They think, oh, V3 must be 12 because 12 is the 3rd term. No, it's because we start with this initial V of 0. So everything kind of gets pushed back because of it as an effect from it. Now this last one here is what really confuses students. And this is pretty much the main crux of the terminology itself. V of n plus 1 just means the next term in the sequence. That's all it means. Now students will ask, why don't you just put V of the next term in the sequence? No, V of n plus 1 specifically is that, because n plus 1 just means, well, if we start off with V of n, which is any term within a sequence, to get the next term we just have to add 1 to it. That's all that means, and you'll see what this means when we get to these examples here. So let's have a look at the starting value of 7, and the rule is to add 4. Now this is the easy terminology. The math terminology of this is, we know what our initial value is, we know what our starting value is, it's 7. So we write V of 0 is equal to 7. Now this is the whole process of getting the recurrence relation. To get the next term, all you do is you get the previous term and add 4. So if I were to read this as a sentence, this just means to get the next term within the sequence, I have to get the previous term and add 4. And you can see why this terminology is being used, because let's just replace n with 8 iterations. Okay, so n is 8, so there's been 8 iterations. So let's just say n is 8. So this Vn plus 1 is equal to V of n plus 4. And this is just saying, anywhere we see an n rather, we'll just replace it with an 8. We see an n here, so we're going to replace this with an 8, and 8 plus 1 is equal to 9. So to get V of 9, we're going to get, with the 8 here, V of 8, and just add 4. So to get the 9 iteration of a sequence, just get what V of 8 was from the previous term, and just add 4. So in order for me to get V1, all I had to do was just get V0 and add 2. In order for me to get V of 2, I had to get V of 1 and add 2. This is what the terminology means. So let's look at another one. A starting value is 3, and the rule is we're going to multiply by 2 and then add 1. So the easy part, writing V of 0 is equal to 3. Iteration always, recurrence relation, sorry, it's always as a V of n plus 1 is equal to, it always starts with this. The value, V standing for value, n plus 1. So to get the next term, we have to get the previous term and multiply it by 2. So 2 times V of n being the previous term, and just add 1. So it takes a bit to get used to with this new terminology, but with a bit of experience and a bit of practice, you should get the hang of it. So write a recurrence relation for the following. We've got a starting value of 10, and the rule is to multiply by 2 and subtract 1. So example 1a, starting value is 10, so our V of 0, so our initial is 10. This is the easy part. And the rule is to multiply by 2 and subtract 1. So we always start with Vn plus 1. In order for us to get the next term, we have to get the previous term, multiply it by 2. So that is to get the previous term, multiply by 2, and then subtract 1. That's all there is to it. B, starting value is 2. And the rule is multiply by half and add 3. So V of 0 is equal to 2, that's our initial. To get the next term, V of n plus 1, we have to multiply by half, so half of V of n, and then add 3. Or this can be written as V of n plus 1 is equal to V of n divided by 2 plus 3. Both of these will suffice because multiplying by half is also the same as dividing by 2. Find the starting value and rule, and then write a recurrence relation for the following number sequences. We know that a starting value in this case is 2, and it's always the first number within the sequence. V of 0 is equal to 2. Now let's try to figure out what this is going up by. I think I can see a common difference of 6, so this is adding 6, adding 6, adding 6. Okay, easy. V of n plus 1 is just getting the previous term, V of n, and adding 6. The next one, we have a sequence that starts off with 5, it's going up to 15, and then 45, and then 135. Doesn't seem like we're adding a consistent number. It looks like we're multiplying this by 3. So our recurrence relation, I should be very specific because a rule is something different, which we'll get to in the next video. V of 0 is equal to 5. To get V of n plus 1, we take our previous term and multiply it by 3. So we can just write that as V3n, or 3 times V of n. Find the first 4 terms of the sequence defined by the recurrence relation. V of 0 is equal to 3, and V of n plus 1 is equal to 2 times V of n plus 1, showing all steps of the calculations. So our initial is v of 0 is equal to 3. V of 1, and these are the steps that you need to show. The v of 1 is just getting v of 0, is getting 2 times v of 0, I forgot that little 2 in the front, then adding 1. So this just can be written as 2 times 3 plus 1, which is equal to 2 times 3 is 6 plus 1 is 7. To get v2, we need to get 2 times v of 1 plus 1. So to get the next term, you get the previous term, multiply it by 2 and add 1. So this is just 2 times what v of 1 was equal to, which is 7, plus 1. 2 times 7 is 14, plus 1 is 15. All right, now how many does it say? First 4 terms. So we've got 1, we've got 2, we've got 3, we got one more term. V of 3 is just equal to 2 times v of 2. So to get the next term, we get the previous term, multiply by 2, and then add 1. So this is 2 times 15, as v2 is equal to 15, plus 1. 2 times 15 is equal to 30. 30 plus 1 is 31. So our number sequence, 3, 7, 15, 31. Now your calculator can also be used to generate a sequence, and there are 2 ways that we can do this. The first one is you can use the main screen, and the second one is to use the sequence app. So the first example, or example 4 in this case, is going to be looking at the main screen, and there's a little snapshot here that you can see. We want to get the first 6 terms by the sequence defined by the following recurrence relation: v of 0 is equal to 12, and v of n plus 1 is equal to v of n minus 4. So we're just subtracting 4. Now this just shows that when you put it into your calculator here, when you click on the main screen here, I'll just go ahead and clear all of this. You start off with the main or initial number, which is 12. So you just type in 12. You also got to make sure that you press execute, and so the calculator can see, yep, this is what we executed, here's a 12. Then all we need to do is put in what the rule is. In this case, you get the next term, you get your previous term, and minus 4. And all I've got to do is just put in minus 4, okay? Now make sure that when you're putting this in that you're pressing the minus button and not the negative button, because if you put the negative button, it's not going to know that you're relying on the previous number that you've inserted. But by putting the minus in, it shows, oh, hey, we have to rely on what was just put in before. Execute this and you'll get 8. And then again, type in minus 4, execute that, and this will keep happening until you get the first 6 numbers within the sequence. So in this case, obviously we know, because it's such a easy one, you start off with 12, you go to 8, 4, 0, negative 4, negative 8. And those are the first 6 terms within the sequence. But the other way, and the main way that we're going to be looking at, is using the sequence app. So we're going to look at finding the first 6 terms, and we're then going to graph it as well. So our initial amount is negative 5, and the rule is we're going to get the next term, we get the previous term, multiply it by 2, and then take away 3. Now automatically I know that because this is starting with a negative number, when we put it into the sequence, we're going to keep generating negative numbers. And in fact, this is going to go down from left to right when we graph it. But for now, we'll go into menu, and you'll see that there is a button here called sequence. It's in blue. Click on this. Now, if you've already got stuff in here, just go ahead and go edit, clear all, and make sure everything is clear here. Now, in this case, they use a of n plus 1. You want to, it makes no difference, just make sure that you're using the same terminology when putting it into the actual section here. So the rule is we need to get 2 times the previous term. So make sure you write 2 and put the multiplication symbol. Remember, mine looks a little bit different because I'm on the emulator. You would just put times. Please put that times. Don't just put 2 and then the next turn. Make sure that there's a time in between. Now to get a of n, you go ahead and click on this button here and then choose a of n. Okay, so 2 times a of n, and then we're also gonna minus 3. Now before you press execute, you wanna go and hit down, and you've got to tell the calculator what the initial number is. In this case, we're starting with -5. Then go ahead and execute this. All right. Now, when you execute this one, if you execute it when the cursor is here, sometimes it doesn't tick that box. But when you execute it, if you put your cursor back and you execute from here, it then goes ahead and ticks the box. But you can just go ahead and tick it manually using your stylus. Okay. Make sure that this is ticked. Okay. Now the first part is done. That's the simple part. The next part is actually quite simple as well. We want to get the first 6 terms within the sequence. So we're going to click this button here where it has the X and the Y with the 2 arrows. When you press this, you're making sure that your starting value is 0 and your end value is... Now, I put 6. It doesn't necessarily matter. Technically, it should be 5 because you get in the first 6 terms. 0, 1, 2, 3, 4, and 5, which counts to 6 numbers. But just to play it safe, you can always end it at the 6th one. It does not necessarily matter. As long as you make sure you get your table by clicking this button here that shows the first 1, 2, 3, 4, 5, 6 terms here. Okay? That next one doesn't necessarily matter for this example, but if it said first 7 terms, then you will include when n equals 6 iterations. So that's how you get your table. To graph this, if you want to graph this, you'll go ahead and press this button here, and this is the graphing button. When you click on this button here, it will graph it. Now, sometimes it might not graph it to the correct screen to what I have here. So in order for you to change this, we're going to click this button here. And what this is a view window screen. On here, we want to tell the actual calculator, well, where do we want our X values to be from smallest to largest? And where do we want our Y values to be from smallest to largest? The X values are just the iteration values. So usually this starts with 0, but I always just go negative 0.5. I want it a little bit left of the screen. And then our maximum value, it really depends on how many terms you've got here. So I want to see the sequence maybe for the first 5 terms. So I'll put 5. Scale, always leave as 1. And don't worry about the dot, I'm not too sure what that is. The next one is your Y minimum. Now, in order to get the Y minimum, if our max value or the max iteration is going to be 5, when we see the 5th value here, this goes to negative 253. Maybe I can push this down to say negative 260. So I've gone just a bit past what the 5th value is. I can just make it negative 253, but you probably won't see the dot. It might get cropped up. And then the max value, because there are no positive values for the A of n, we'll just leave it as 1, doesn't matter. Press OK, and I'll resize that, and that's what you should get. So it's going down, and it's going all the way down. See, I should have probably made the maximum maybe 5.5. Let's make it 5.5. There we go. Because it's 5.5, it's pushed it to the left a little bit, so that way you can see, okay, that's where the 5th iteration happens at this point here. And you can see it just trails down, just like that. And that concludes this lesson. Go ahead and check your log sheet to see which questions you need to do, and I'll see you in the next video. Bye-bye.